Hi, Dana Edge here. Let's talk about the point slope formula and parallel and perpendicular lines. There are two ways to write an equation of a line. When you know the slope, they both require that you know the slope of the line, but not the y-intercept. Let's say you are supposed to write the equation of the line with the slope m equals 2/3, and it goes through the point, I don't know, 5, -3. Doesn't matter what the slope is, and it doesn't matter what the point is. Okay, the first way is you can use the slope-intercept formula, y equals mx plus b. To write the equation with this, you have to fill in the slope and you have to fill in the y-intercept. And we know the slope is 2/3, but we do not know the y-intercept. You cannot just use -3 for the y-intercept. To be the y-intercept, it would have to be the point 0, -3, which it is not. And I know for a fact that the y-intercept is not going to be -3, because to have both the point 5, -3 and the point 0, -3, that would require that it have both this point, and the slope would have to be 0 because it's a horizontal line. The slope is not 0. So the one number I can absolutely guarantee is not going to be b is -3. We can, however, use this as the x and the y values, because the equation has to work for every single point that's on the line. So we can plug these in, not for b, but for x and y. Here's m. We can do that and solve for b. So I would have -3 equals 2/3 times 5 plus b. -3 equals 10/3 plus b. -3 minus 10/3 is b. This is over 1. I got to get a common denominator to add these, which would be 3. So this would become 9 minus 9/3. Let's see, now that's a minus, sorry. I lost my minus here. And minus 10/3 would be minus 19/3, which is b. So the answer is going to be y equals 2/3 x minus 19/3 if we leave it in slope-intercept form. The second method is to use what is essentially the slope formula Now recall that your slope formula is y2 minus y1 over x2 minus x1. If you take this formula and you multiply through on both sides by your common denominator, x2 minus x1, then this becomes m times x2 minus x1 equals y2 minus y1. Rather than distributing this, I'm going to leave it like this, but I'm going to erase, well, that didn't quite work out like I thought. I'm going to erase the first set of subscripts, and they usually write it in reverse order. Y minus y1 equals m times x minus x1. So this is nothing but the slope formula multiplied through by the common denominator. They call this the point slope formula now. So whether it's the slope formula or the point slope formula, just depends on what format it's in. You can use this to write an equation of a line by plugging in you want to go plugging in m and any one point for x1, y1. So we've got an m, we've got a point to use for x1, y1. So to use this formula, we would put y minus -3 equals, let's see, the slope is 2/3 times x minus 5. This is y plus 3 equals, if I distribute this, I'll get 2/3 x minus 10/3. You notice we got the same numbers coming up as before. Subtract 3 from both sides. Gives me y equals 2/3 x. That's still 3/1. Multiply to get a common denominator, so that would be a minus 10/3 and a minus 9/3. So we get y equals 2/3 x minus 19/3, which is, of course, the same thing we got before. The advantage to using this formula is that when you're done, you're done. You're not just solving for something to go back and plug in. Here you're solving for B. And then you rewrite the equation using x and y and replacing B. Here you're done, but it means learning another formula. The results are going to be exactly the same. So to use the point slope formula, and I don't care which way you do it. So if you're used to using the slope-intercept formula, solving for B, that is absolutely fine. The amount of work involved is the same. To use this, you have to plug in the slope, m, and any one point you plug in for x1 and y1. Now, what if you didn't have the slope? What if it said, write the equation of the line through the points, I don't know, 2 minus 7 and 6, 8. Okay, we got to plug in m. Well, first we find m. We've got 2 points, find the slope. So I can let this be x1, y1, x2, y2. I'm using the slope formula. Subtract the y's over subtract the x's. So it becomes 8 minus -7, 8 minus -7 over 6 minus 2, which would be 8 plus 7 over 4, which is 15 over 4. Now I've got the slope. I can use whichever point I want. It does not matter. The line has to work for every single point that's on the line. So I can do y minus, oh, well, this one's got all positives. Let's use this one. Y minus, let's see, the y is 8 equals 15 fourths x minus 6. Y minus 8 equals 15 fourths x minus, let's see, 90 over 4. So if I'm going to add 8 to both sides, I've got 15 fourths x minus, let's see, this will reduce down to 45 over 2, just this. So I can multiply this by 2 over 2, which becomes plus 16 over 2. You have to be able to add fractions. Negative 45 and a plus 16, subtract, minus 29 halves. Had I used the other, that would have been y minus a -7 is y plus 7 equals 15 fourths times x minus 2. Y plus 7 equals 15 fourths x. Of course, we already knew it was going to be 15 fourths x minus 30 over 4. Subtract 7 from both sides. Well, I could reduce that, but it doesn't matter when I do it. So 15 fourths x minus 30 fourths. I'll go ahead and write this out. Minus 28 fourths. Is going to be a minus 58 fourths. And 58 fourths will reduce, divide that by 2, divide that by 2. $29. Oh, sorry, halves. And if I had used y equals mx plus b, it would have given me the same end result. I would have had to do the same work with the fractions. It wouldn't make any difference. Let's do a little bit different topic here. Parallel lines. Parallel lines are lines that never cross. They go through life with the same slant all the way, so they have the same slope. Suppose suppose they asked you, are the lines 2x minus 3y equals 6 and y equals 2/3 x plus 5 parallel? How do you know? Well, we already know the slope of this line. The slope of this line is 2/3. To get the slope of this line, we need to solve it for y. Never takes but 2 steps. Subtract 2x from both sides. So minus 3y equals, I'm going to go ahead and put this term first, but it doesn't matter. The slope is the coefficient of the x. It's not the first number or the second number, it's the one that's multiplied by the x. So if I divide by -3 all the way through, I'm going to get y equals a positive 2/3 x minus 2. The slope of this line is 2/3. The slope of this line is 2/3. So the answer is absolutely yes. Now, perpendicular lines. Have slopes which are opposite, which means different signs. Reciprocals. Which means 1/. In other words, the lines y equals 3/4 x plus 5 and y equals a negative 4/3 x plus anything, 7, are perpendicular. You have to both change the sign, so this one's positive, this one's negative, and flip it over. It's not enough to do just one or the other. To get a picture of that and understand why, let's say we've got a line coming through here. Now the slope of this line would be this rise over this run. So this looks like about a 3-to-1 ratio. This looks like up 1/3. It would be positive because it's increasing. So I can estimate that the slope of this is approximately 1/3. The slope of a line that was 3 might be like this, where it goes up 3 and over 1. It would actually be a little steeper than this, but it's not going to be anywhere close to being perpendicular. There's no way these two would have to be the same. If I took a negative 1/3, so let's say this is about 3, a negative 1/3 would be about like this, where this and this were about the same lengths, but one's going down and the other one's going up. So this could be about 1/3, and this could be about negative 1/3. And it's not perfect, but you can see there's not anywhere close to being at right angles, which is what perpendicular means. However, if I take one that's about 1/3, so the slope here is about 1/3, the slope of a perpendicular line would be a -3. So it would have to go down this much and over this much and go down. So it would be about like this. So the slope of this line would be approximately, rise would be 3, run would be a -1, which is a -3. And you can see that these do look pretty close to being right angles. So to be perpendicular, the signs must be different. And the number part must be reciprocals. So they typically give you some problems where they'll give you two equations and they'll say, are these lines parallel, perpendicular, or neither? And of course, anything other than either exactly the same or having different signs and reciprocals, anything else just qualifies as neither. We are not going to do the part about curve fitting and correlation lines. So don't worry about that. This will be it for the week as far as new material. Let me know if you have any questions, and I will talk to you later.